Here are three solved gas law problems. In the first one, we have a 0.4 liter engine, so that must be our original volume. It's at 2 atmospheres of pressure. That's our original pressure. I recommend you solve these just like this. Put the identity of the units right near them so you don't have to fool around. It's very efficient. We're going to increase the pressure to 20 atmospheres. Notice that's a 10-fold increase when the spark plug fires, and they want the volume at that greatly increased pressure. In your head, we could say that, okay, the temperature's constant, so this looks like P's and V's, Boyle's law. And if the pressure is going up by 10-fold, the volume must be going down by 10-fold, squeezing it down to a higher pressure. The answer should be 0.04 liters. We can solve that mathematically by plugging into the Boyle's law formula. 2 atmospheres at 0.4 liters of volume will be equivalent to 20 atmospheres at a greatly reduced 0.04 liters of volume, and it checks out. Here's another problem. We got a 2-liter balloon, and there it is. Let's heat it until the gases inside warm from 25 to 323. Well, we've got our original volume, and we've got our temperature, but always use Kelvin because this looks like it's increasing 4, 8, 12, maybe 13 times. But if you switch it to Kelvin, you see that, in fact, it's just doubling. Remember to get Kelvin at about 273 to your Celsius. Therefore, if the temperature is going to double, I think that thing's going to expand. I think the volume will double to 4 liters. No need for any math. We're done. If you wanted to solve it, plug into the Charles' law formula. Since it's a proportional effect, these are expressed as one over the other, and it doesn't matter which one's on top as long as it's consistent. In this case, we put temperature on top. And we solve it by cross-multiplying, and we get the predicted answer of 4 liters. A third law. We got a closed, fixed aluminum can with only air in it, and it can handle 4 atmospheres of pressure, and then it will burst. So it's a 2-liter can. That must be our volume. The pressure is 4 atmospheres, but since the volume is not changing for this thing, we must ignore it, meaning we're dealing only with temperature and pressure. That means it's gay-Lussac's law. And we have an initial pressure. We want to see if we exceed this pressure. And we have a temperature initial, which we've converted to Kelvin as we must, and we have a final temperature. But it looks like it's only going up, not even doubling, maybe 1.2, 1.3 times, something like that. So the pressure should go up to not even doubling. Therefore, if it can handle a pressure of 4 atmospheres, we're nowhere near it. The answer to this question should be no. So in our head, we're saying the temperature's going up a little bit, so will the pressure, but it's only going up to like 1.5 or a little more. It won't burst. Solve it mathematically by memorizing the gay-Lussac's law formula, or just realizing it's a proportional one, so we have to express it as one over the other. Plug in, cross-multiply, get your answer. Very close, how do you like that, to our predicted answer? Nope, it will not burst. Those are 3 gas law problems.